Hello there. Now we know the basics of creating objects, rather custom objects in nanoCAD Mechanica. We will now look into the complex objects development. You can say we will find some of the standards, maybe IS standards. Here we will use the clip spin, headless clip spin. So we will create these objects, IS 6862B. So I will copy the code, the item code. So we will find how to add this type of objects in nanoCAD Mechanica. So to do that, obviously you need one DWG file. Their views will be there drawn with the parameters, with the different templates with different variables. You can use this JPG as a preview image for the item, and obviously you need the Excel. This is very important. Every company has their own product catalog, so they need these informations, right? So in this case, as we are dealing with IS objects, so this informations were copied from the IS standard, right? So as you can see, it has the variable names and the variable descriptions. So ND stands for nominal diameter, NL stands for nominal length, and so on, right? So this is the Excel informations, this is the image, and this is the DWG file you need. You can forget this. After you create the objects, you can make this type of MCD to send to someone else to use on their local system, the same copy of objects. So to create the IS6862B, you need the DWG and image and the Excel, right, with the data. So now let's go to nanoCAD and find what inside this IS6862B. So we have top view, and then we have front view, and we have side view, right? And in this view, as you can see, we have different variables. For instance, nominal diameter here. So based on this nominal diameter, we have formulated one more dimension, that is nominal diameter into 1.35 minus nominal diameter divided by 2, right? So this is how it works. The entire 2D drafting will be flexible, and it will be depend on the variable, right? So these equations can be found on the IS standard book, or if you are doing for some specific companies, then those companies should have their own manuals, and those manuals, a designer will definitely put these instructions how to get the corresponding informations. So you can use CAD, you can use nanoCAD for drafting this, or nanoCAD Mechanica for drafting this, and you can create this drawing and assign these variables. And we have more. We have front view, side view, but remember, these views will depends on the same variables, nominal diameter, right? So nominal diameter is everywhere. So based on that, all the variables were assigned on each and every views, right? So this is very good. And this is sort of the this is the hierarchy where you can find the IS6862B items already added in nanoCAD Mechanica. This is for your reference, but this is created because of you to show how these things were added to the library and how things work. To show you, we have created this, right? So let's go further and test the model. As we said before, that before you go for the script master in the Make Wizard, you need to test the model, right? So if you have properly assigned the variable everywhere, and if it really makes sense, then it will be successful. The sketch will be successful, right? Successfully recognized. So this is okay. I'll go for the front view. This is fine. I'll go for the side view. So this is again okay. So I'm good with the sketches now. So now I can go to the script master, and I'll create new, and this is okay. I want to create the item in this directory, so I'm okay with this. And the name I already copied, so this will be the name, and I will not write anything. So I'll start with the default template. Later on we can use these options to take reference from other objects, but for that you need to understand the basics. So our suggestions will be to you to go with the default templates for now. I'll press OK. So now we will go to implementations. We will right click and add implementation. So now I have one view. So I have total. So I will add two more here. So here I'll have to find. So I'll have top view. So I'll take the top view, and I will recognize the top view from the drawing. So this is my top view. Make sure you put everything inside the selection window and then hit enter, and it is recognized, right? So this is the top view. If you double click, you will get the code base, but you don't really need to do anything with that. Sometimes there's a need to update something, but for now you can avoid this. right? And then we will go for the front view. So this is very important. You will have to, I mean, for this I selected the top view. For this I will select this front view. So I'll right click and I will recognize this. So I will hit enter again. This is fine. And now I will go for the side view. So on this case, maybe I can go for right side view. That's fine. And then I will click parametric recognize view. So this is my side view. Excellent. So now I have all the implementation, all the sketches inside MacWizard window. And now I can go for table. And this is interesting. The earlier video where we have seen we were created the variables name manually and data type manually, but here we will not do that. We will directly go to that Excel provided by the IS standards, or in your case it will be the design engineers. So I'll choose Excel and wait for a minute or two. It will import all the data. So this is a big list of informations. So it's 467 is a big informations, right? And once you created this, there will be no need for you to create these objects manually ever again, because if you design some new data, you can fit inside this and you can create the same objects automatically. So now we are ready and we'll go for this object preview. So here we are going to use images. So this is the clips pin. So I'll use clips pin image only, not 3D preview. You can create your own to use it, but for now we will use the image. So I will keep my selection here. For now I will say save. So if you see on the MacWizard window, we have worked three places. So this is the number one, implementations, and then table, and then the preview. So we will be on table, and rest of the informations we will discuss in the upcoming videos, right? So now we will go for the script master. So we'll go for the script master window. Okay. So now we can write clip spin, or maybe you can give the code. You can use the same code here. So this is the object name or description, or you can say this is the clip spin. You can write it. You can also use the name. It depends on the instruction given by the designers or IS standards. So I'll click next. So I don't need this to be appeared on the dialog box to the users. I need only nominal diameter. So I'll choose ND for nominal diameter, and the value is 3. So I'll have to choose one value and the corresponding value, and I'm saying this should be available on the dialog box. I need nominal length as well. So this is nominal length, and the corresponding value of 3 is 6. So I'll press 6, and this is also should be available for editing to the users. And as you can see, this is a tick mark, and rest of the other variables are crossed. So that's all fine. It will be there helping the entire model from the behind, but it will not be appeared on the dialog box that user will find while they will be using the components, right? I'll press next. We will not discuss about the calculations for now. I'll press next. I'm okay. Press next. I can insert this so that I can find the objects while I will be inserting the objects. So I will select this as well, and maybe this option as well. So I am done. I will say save. Okay. So our development, we can say that the dialog box should appear with the nominal diameter and nominal length to the users, right? And other corresponding values should be appeared when we will choose some of the nominal diameter of this clip spin. So let's say we will move slightly out of that specific source string. We'll refresh the window. Once we refresh, it will appear here. So here we can see IS6862B. So now we can see the clip spin rightly displayed in the preview. And now as you can see, while we are inserting the objects, now we can find on the screen. Now this is the miracle. I mean, now we have different tab here as well. So now we have different tab where we can find that if the nominal diameter is 3, then where we can find that if the nominal diameter is 3, then nominal length will be 6, and so on. So if we choose 20, it will be something 70. So we have this type of variations in the object. So we can select that. We can say okay, and it will be bigger than what the initial size was. So now if we double click again in it, the editing dialog box will appear, and then we will change the preview, and this is how it works, right? If we double click, we can change the size, right? And definitely if you right click on this, it can be import or export some pen drive for other users, or the user can keep on the server and everyone in the company can use it. Most importantly, if you need to add some other specifications, values, you just right click and go to extreme down here in the table, and right click and add one and give the value. It will be added, so you don't need to draw anything, so the drafting will be there automatically, right? So in the next video we will see one more objects, sort of similar how we create the objects, and then in the future videos we will discuss each of these components, how the set parameter works, the insertion point, symmetrical objects, test model, parametric array and dimensions, and so on. So we'll discuss later on, but for now get the idea how things work, and how we can make it possible to add complicated objects in the library and reduce the drafting time, right? And obviously the possible error that can be added by the users, so that will be eliminated completely. Thank you very much for your time. See you in the next video.